Hello everyone, this is a very brief introduction to one interesting tool for IoT applications, which is the Arduino platform. So we will see a very general introduction to Arduino and its application that it's useful to start playing with this nice and easy to use tool. Okay, what is Arduino? Arduino is a hardware platform for rapid prototyping, and it has many boards. We have many boards with microcontrollers, different shapes, different sizes, but all based on the same open source architecture, and it easily integrates sensors and actuators because it is fully open in terms of hardware and software. It is programmable via a multi-platform integrated development environment that uses C-like language, and it's pretty easy to use. And the programs are typically named sketches, and you can see everything. You can start working on Arduino by looking at the reference website, which is www.arduino.cc. The development environment is fully open source. It is available on all platforms, so Linux, Windows, Mac OS X, and it is easy to write code inside this tool and upload the sketches on the board, because you work on the PC and you must upload the code once compiled for Arduino to work on the processor that you have on each different platform. So we have inline syntax verification, and it supports all the possible board flavors. Yes. So presently we have 16 different boards in Arduino, and they all use the Mega AVR series microcontrollers, and are equipped with both a voltage regulator and a quartz oscillator. It's kind of a professional tool, even if it's still open source and very cheap to buy. We have expansion boards that are called shields, and you can find the shield list at this reference website. So, in order to take something as a reference, we start working with Arduino Uno. It is based on the microcontroller ATmega328P, so it's a 8-bit RISC architecture, and it has an operating voltage of 5 volts, but the recommended power supply is from 7 to 12 volts. It provides 14 digital I/O pins, of which 6 are can be used for pulse width modulation at 8-bit. And we also have 6 analog input pins, and each pin can provide a current up to 20 milliamperes, which is suitable enough to light a LED diode, but it's not for other applications. So pay attention, because if you want to connect devices that require more power, you should use other solutions, not direct connection. We have an integrated flash memory of 32 kilobytes, which is pretty small, but for some application it's enough. And it has a static RAM of 2 kilobytes with operating clock of 16 megahertz, which is ridiculous in terms of what normal CPUs use, but it's very it's it's been very tailored for this microcontroller, so it's perfect because it works very well. This is a picture of the hardware board. You can see the details for the power input, the voltage regulator, where the quartz is, the other microcontroller for USB communication. There's a reset button. There are jumpers for configuring the USB interface, and also for connecting an external USB interface. And also there's a detailed pinout for connecting all for understanding what is the possible usage of all the pins of the 40 the connector. Okay, so you can see there the pins that support the PWM are identified with this tilde symbol, and are those are, for instance, 9, 10, 11. They're placed in not all one after the other, but distributed along the connectors, because maybe it's better to have a flexible layout, a pinout to use. We also have a reset button and a reset input to connect to use. Okay. Here is a short explanation of what pulse width modulation is. It's a kind of a digital modulation that provides a variable average voltage depending on the duty cycle. The duty cycle is simply the ratio between the time that the signal stays at level 1 and the time of the period, the duration of our uh, oscillation. So in this case, you can see that we can modulate the average voltage by changing the duty cycle. So if the duty cycle is 25%, we have an average voltage which is low, and if you increase, you can have an average voltage that goes from 0 to 5 volts. Which is average on all time. So it's important. You can see also an example here of what is the signal modulation using two different sources. One is a sawtooth signal, the blue one, and the other one is a sinus, and you obtain a PWM signals that it's proportional in terms of average to the modulating signal. From the installation of the IDE is very easy. You can download the software from the official website and follow the installation instructions. Then you connect the Arduino board through the USB connector, and you must select the correct board from the proper menu item. Otherwise, it doesn't work. You cannot download the software, or maybe you can download probably, but you cannot make it work because the different how do you say is instruction set of the different microcontrollers. So you can also try and copy an example that I reported on the following slides to make it easier for you to try your board, and you press upload to sketch to upload the sketch on the target board. Then the board starts working. The structure of a sketch is made up of two parts. First, we have a section, well, two parts in terms of a section that it's important to define the global variables and contrast definition. there's and then the second part is the functions, which again are two basic functions. One basic function is executed is a setup function, and it's executed only once at the device startup, and it is useful for initializing the variables or define an initial setup of pinout and so on. And the loop function is where the real program works and it is being executed, and it's an infinite loop that always keeps processing the instruction until the program until the switch off of the device, because the program never ends. So here we have an example sketch that you can see. We have the setup function in which we initialize the pin, the LED built-in pin as an output, because there's every board has an integrated LED that is associated to a specific pin. And so we can just to test it, we can just connect it to this pin, and then start looping over the cycle. And we have you see that we write high level, so we set it to switched on the LED, and then we wait for a second because the delay is expressed in milliseconds. Then we set it to low and we switch it off, and then we wait for another second, and we keep flashing 1 second after 1 second. So how to develop application in a way. If you don't want to use the soldering iron, you can simply use these breadboards that are simply plastic tools in which inside the connections are on the same column for the central bands, and because they are vertically connected, and also we have horizontal connections for power supply on the external bands. So the external bands, and these can be used to connect every type of component, and to create a very simple but interesting experiment to use the device. Another option is to use Tinkercad, because there's this circuit simulation with Arduino that you can find at this website, and you simply register for free and you start using it. It's good, but because you have the possibility of choosing your Arduino device and simulate the behavior of a board, more or less, with all the possible shields and all the possible components. You can set resistors, you can add capacitors, you can add LEDs and integrated circuits and so on, and create your prototype and simulate a prototype and verify if it works and how it works. It's kind of electronic experimental board. And that's it. So thank you so much for your attention.